Welcome to what is going to be an absolutely awe-inspiring explainer. Today, we're jumping right into a cosmic journey to figure out the dramatic, and I mean really dramatic ways, the most massive stars out there and their lives. We're talking about events so unimaginably powerful, they literally forge the building blocks of the universe. I'm super excited to be your guide as we dig into the what, the why, and the how of these stellar destinies. So get ready, we aren't just casually stargazing today, we're going to deeply understand the violent, beautiful physics behind their final moments.
To set the stage, let's start with an incredible reminder of divine design. You know, thousands of years ago, way before the very first telescope was even a thought, the ancient text of Job chapter 26, verse 7, marvels at how the Creator stretches out the north over the void and hangs the earth on nothing. It perfectly frames our scientific exploration today with this profound sense of wonder. It reminds us that the mechanics of the cosmos, they aren't just random, chaotic accidents. They're part of a grand, majestic, and beautifully balanced system.
So, picture this. You're looking up at the night sky on a completely clear, perfectly dark night, and you see thousands of twinkling lights. Have you ever wondered what actually happens when those giant, massive stars finally run out of gas? Because, fun fact, not all stars go out quietly. A smaller star, like our sun, it'll just gently fade away over billions of years. But a truly massive star has a much, much more dramatic destiny waiting for it. And when I say dramatic, I mean it's one of the absolute brightest, most violent events in the entire universe.
To wrap our heads around what causes a star to literally explode, we have to look at this epic, cosmic tug-of-war. For a massive star's whole life, there are two competing forces at play. On one side, the star is constantly burning nuclear fuel, which pushes this tremendous amount of energy outward. But at the exact same time, its own massive gravity is constantly pulling everything inward. Well, when the star finally runs out of fuel, that outward push completely stops. Gravity wins the ultimate victory. It forces the star's core to collapse inward so incredibly fast and so hard that it violently rebounds in a brilliant, blinding blast. And that right there is what we call a supernova.
Now you might be asking yourself, why should I care about some explosion millions of light years away in the dark? Well, because a supernova basically acts like a giant cosmic factory. The extreme heat and frankly unfathomable pressure of this blast actually forge the heaviest elements in the universe, scattering them violently across space. That gold in your jewelry, the oxygen we're breathing right this second, they were literally blasted into the void by a dying star. And over millions of years, they clumped together to form new stars, planets, and even life itself. It's wild to think about, but you are literally made of star stuff.
And this brilliant aftermath? This is known as the Crab Nebula. It's a breathtaking cloud of glowing gas and dust left over from an actual supernova explosion. But here is the coolest part of the story. Ancient astronomers living back in the year 1054 AD actually witnessed this exact explosion from Earth. No joke, it was so unbelievably bright that for almost a whole month it could be seen shining in the sky even during the daytime. What those ancient stargazers thought was a bright new star appearing out of nowhere was actually the fiery, spectacular end of an old one.
So, the outer layers of the star have been completely blasted away, creating these beautiful nebulas across the cosmos. But once the dust settles, what happens to that dense core left behind in the dark? It doesn't just vanish into the void. Depending on just how massive that original parent star was, its surviving core is going to face one of two totally bizarre, mind-bending destinies. Let's break down exactly what those ultimate fates look like.
If the remaining core is incredibly dense, it crushes down into what astrophysicists call a neutron star. Imagine taking something with more mass than our entire sun and crushing it down, just tightly packing it until it's the size of a single city. Just a city. That's a neutron star. But if the core is even denser and heavier than that, it collapses entirely in on itself. It becomes the ultimate cosmic mystery, a black hole. A black hole is the single densest object in the universe, where gravity is so terrifyingly powerful, it actually warps the very fabric of space and time.
What's really fascinating here is how some of these neutron stars behave. As that giant star's core collapses down to city size, the conservation of momentum means it starts spinning incredibly fast. We're talking sometimes hundreds of times every single second. As it spins, its intense magnetic field shoots out these massive, sweeping beams of radio waves from its poles. And if those beams sweep past Earth, our telescopes detect them as highly regular, rhythmic pulses. Scientists call these rapidly spinning neutron stars pulsars, and they essentially act as the most accurate cosmic lighthouses in the entire universe.
But let's shift gears and look at the heavier sibling, the black hole.
Its very name tells you it's completely pitch black. But wait a minute. If light is the absolute fastest thing in the universe, traveling at an astonishing 186,000 miles per second, why exactly can't even a beam of light escape a black hole's grasp? What is happening on a fundamental physics level that makes this object so completely inescapable?
The big takeaway here is its extreme gravity. Remember how a massive star collapses? Well, in a black hole, that collapse literally never stops. All that matter gets packed into an infinitely small point called a singularity. This creates a gravitational pull that's so incredibly powerful it physically bends space and time inward around itself. Think about that for a second. It creates a gravitational well so infinitely steep that the escape velocity, the speed you need to get out, is actually faster than the speed of light. And since absolutely nothing can travel faster than light, well, nothing can ever escape once it crosses the edge.
Which naturally brings up a really great question. If no light can escape a black hole, and it's completely invisible against the dark backdrop of space, how do we even know they exist? Well, we can't see them directly, but we can detect them by playing cosmic detective. We carefully observe how their massive gravity pulls on the nearby stars orbiting around them. We can even see how their immense gravity literally acts like a giant magnifying glass, warping and bending the light from distant galaxies that are sitting way behind them.
Okay, as we bring our cosmic journey back down to Earth, it reveals a pretty profound parallel. We've seen how physical laws govern the orderly balance of the universe, right? But what about the laws that govern our own lives? Understanding the mechanics of supernova and black holes is an absolute testament to human intelligence and curiosity. But it leads us to an essential question. What's the point of being highly educated and incredibly smart if we don't have the internal wisdom to make good choices?
This is where the Academy Godly Learner series points out a stark difference between just racking up facts and actually attaining true wisdom. It argues that being educated on the science of the stars, or really any intellectual subject, without a solid foundation of biblical morality, can lead us to make directionless or painful mistakes that hurt ourselves and the people around us. We might be exceptionally smart, sure, but completely morally adrift. On the flip side, blending a strong education with morality creates a spiritually focused learner. It ensures that our brilliant minds are always guided by a compassionate, grounded heart.
And there's a really profound benefit to finding this balance. As highlighted by the text of Romans 8:6-7, keeping the mind focused spiritually brings a deep, lasting peace of mind. It's the realization that, while the external universe is fundamentally chaotic, filled with violently exploding stars and crushing, collapsing cores, our internal universe can remain incredibly peaceful and purposeful. Combining intellectual curiosity with a solid spiritual grounding means we don't just gain knowledge about the world, we actually gain tranquility within ourselves.
So, as we wrap up this explainer, I want to leave you with a bit of a challenge. As you continue to look up at the stars, as you marvel at the raw power of supernova, and study the intricate, awe-inspiring design of this magnificent universe, ask yourself this: how will you combine your pursuit of education with a strong moral foundation? How are you going to take the brilliant things you learn and use them to navigate your own destiny, making choices that build up both your intellect and your spiritual peace? Keep looking up, keep asking those big questions, and I'll see you in the next explainer.